Welcome to Tip Tuesday, and today we're going to talk about the add-edit units of measure. I'm going to turn myself off here real quick so that we can see our screen. And so in the add-edit, you'll find the units of measure under system-wide, and scroll to the bottom, units of measure. So first obvious question is, why do we even have this? And the short answer is because we're doing metrology and calibrating equipment, and there's a huge difference between a 5-inch micrometer and a 5-foot micrometer. So because we're doing calibrations, because we're doing measurements, we're dealing with units of measure, and this units of measure add-edit has a major feature, which is it helps us with doing unit conversions. So I'm going to go ahead and go find length, and we're going to talk a little bit about the unit conversions. And just so you're aware, we can do unit conversions in any of the custom rules or scripts that we can build. We also automatically handle unit conversions when looking up specifications in uncertainty budgets, and you can actually do those conversions inside your budgets as well. I think it's also worth noting that these units show up in a variety of places. So for example, in our test points, you can see we've got a drop down here with units. We've got several of these actually. These also will show up in the specs tab. So you can see here. They can also be exposed in the attributes. So you can expose a unit of measure field with add-edit attributes. So for example, if I go here, unit of measure is one of the attribute properties you can expose. And then we've also got the specifications manager, which has them create structures very similar to specs, and in the uncertainty budgets, which I will be showing you here in a moment. So looking at units of measure, we've got several things on here. So for example, if I look at the inch as an example, we have the unit of measure as it's going to appear in the various drop downs. This is case sensitive because there's a huge difference between a megameter and a millimeter. Group, this basically collects things together. It is your first indicator of what things can be converted to what. Your description, an inch is an inch, foot is a foot, so on and so forth. Resolution, prefix, this is particularly useful. So when you're talking about a millimeter, the prefix is milli, and obviously the base unit then is meter. So here, the prefix along with the base unit is where we would normally get the full name. So if I look at a micro inch, for example, the prefix is micro, the base unit is inch. If I look at an inch, inch is the base unit. The factor is just your multiplier for how you get from the base unit to your unit. So for example, if I look at a micro inch, if I multiply 1,000,000 microinches by 1e minus 6, that gives me 1 inch. So this is the multiplier to go from my unit of measure to the base unit. That will become very important during conversions, because during any uses of our unit conversion function, we first go from the unit of measure up to the base unit, and then from the base unit to the conversion unit. So looking at feet or inches, for example, our conversion unit is m. So the idea here is that for all of our lengths, when we're doing conversions, we're going to convert from our current unit into meters, then from meters back to whatever unit we're interested in being in. So the conversion unit is the unit that everything gets converted through. Then the conversion up, so this indicates how to go from feet, or from this case, from inches to meters. Convert down, converts down from meters to inches. And so I could do something like, say, 12 inches, and if I click test, that's a little under 1/3 of a meter. And if I had 12 meters, that would be about 472 inches. So this is all relatively straightforward. The main reason for the test is to make sure your convert up, convert down functions are correct. So that's an example of inches. We could do the same thing with yards. So if I've got 1 yard, that's 0.9144 meters, or 1 meter is 1.09 yards. Relatively straightforward. If I go to meters, you'll notice that SI and metric are both checked, indicating these are our appropriate units. And so we have this definition throughout. So masses and weights, we can convert these together, power. We have a very large list here, but it is possible that you can find out that you have found a special unit that we missed. For example, if we're looking at length, I'm looking along here and we've got centimeters, kilometers, meters, millimeters. Wait, there's a decimeter. We somehow missed the decimeter. And so I can put in DM, group is length, decimeter, prefix is deci, factor is 0.1. This base unit, this list is going to pull from the units that we have available. Now, for my conversion unit, I'm going to put 1, because what happens is we use this factor to convert the decimeters to meters. Meter to meter is just a conversion of 1. So it's going to look kind of dumb when I hit the test button because it's just using the convert up, convert down right now. We can look into adding this to the factor. However, what's key here is it will work properly when we use our conversion function. So the easiest way to demonstrate how this all plays out with conversion functions is if I go to the uncertainty module. So here I've got my little testing area, and so the first thing I want to show you is unit conversion. So here we've got, you set up your 2 initial variables, the result and the error. Then you're going to say, I want to convert from 1 millimeter to meters, and it's going to have a result and an error, and there's also going to be an overall value. So unit conversion is going to display true or false depending on whether the conversion was successful. So here, if I hit play, so it successfully converted 1 millimeter to meters. It's 0.001 meter, and there was no error. If I try to convert it to grams, Now it's going to be false. The result is 0. And there's not an error message per se, but it just didn't convert. So the error message is only going to happen if something truly screwball happens, like you have a bad conversion formula. So the other area where this can become important is if you're doing lookups. So here I've got a scale, and what's important here is I've got to look up from 0 to 500 milligrams, from 500 to 1,000 milligrams, and from 1 to 100 grams. So this column is my lookup column. So if I look up a half a gram, technically I don't have a half gram range. Now clearly, looking at this, I do have support for 500 milligrams, which we know is a half a gram. So if I do this search, what's going to happen is it comes back with 0.01. And so what happened is it looped through here looking for an exact match unit of measure gram in the half gram range. Couldn't find it. So then it goes back through and does a second loop and says, hey, wait, 500 milligrams, that's a half a gram. Half a gram is in this range, so we can go ahead and use this uncertainty value anyhow. And so what this is going to allow you to do is keep your specifications smaller and express them as appropriately as possible in the desired unit, so 0 to 500, rather than having to list everything multiple times, or rather than having to do a conversion here. Instead, I can say, if I'm dealing with mass, I can grab whatever makes the most sense for what I'm using on my current test point and look it up, and it'll automatically look up what's on the specification in an appropriate unit. So these conversions are going to allow us to make a lot of our logic much simpler. The other thing this will do is we can now take these, and regardless of what unit of measure our test points are, regardless of what unit of measure our specifications are, we can do conversions to make sure that all of our uncertainties are then expressed in the desired unit for our budget.